Hi, my name is Austin Huang, and I'm a student intern with Rice 360 Institute for Global Health. This summer, I was placed on the team of distancing devices, and my teammates are Ruth, Lauren, and Chikambusa. And in this presentation, I will be talking about our current design ideas for the contactless temperature monitor, as well as summarizing what we did throughout our internship. So with the current COVID-19 pandemic, there's become an increasing need to monitor the body temperature at a safe distance because usually in current practice, temperature is taken orally or axillary, and this requires close physical contact between the thermometer and the patient. Therefore, it exposes a lot of health officials or any individual trying to take the temperature to the risk of contracting the virus themselves. So our idea behind the contactless temperature monitor is to address this issue by eliminating the physical contact and therefore reducing the risk of infection. Currently, the standard models that are being produced by businesses are expensive, they're also limited in supply, and sometimes the components that comprise these models are also limited in supply, as well as takes a long time to ship to settings such as Malawi. So when our team was given the prompt of designing a contactless temperature monitor and proposing improvements to the existing model, we came up with a few design criteria. The first is that it should be affordable, and we said that compared to a standard model on the market, it should be less than $60. The next consideration that we put into our design criteria is that the device should display a very accurate value for the temperature, such that compared to the contact thermometer, it should be within 0.2 Celsius degrees. The third thing that we found to be valuable is the amount of distancing that would be allowed between the monitor and the patient. Ideally, it should be what is deemed a safe distance, but it should be comparable to the standard models available in the market. The other categories are mostly related to the use of the contactless temperature monitor. So for example, we believe that it should be durable such that it could withstand a drop test of 175 centimeters, which we found to be the average height of an individual, such that if our device is dropped, it will be able to withstand the impact. Another thing that we considered was that it should be easy to use and intuitive, such that if we were to implement a system usability scale, the scores will be above 70. It should also be lightweight and handheld, comparable to current standard models, as well as easy to power with batteries. So the power requirement should be less than 5 volts, and it should be able to be used multiple times. So once our team came up with the design criteria, we decided to also break down the problem that our device would solve into a few steps so that we could really hone in on which aspects that we could focus on. So the first thing with using our device is that the user will press a button, and this will activate a sensor or laser. And once the signal has reached the patient to get their temperature, and then the signal has returned to our device, the user will be given a feedback, either a noise or a vibration, to release the button. And once the button is released, the sensor will start to filter and really process the signal so that it can be interpreted into a numeric value for the temperature. And at this point, the user will be given a color indication whether the temperature is critically above normal, or just normal. In addition to having a color display, we decided to also include a numeric value itself in case the user wants this extra information. And so once we broke down the problem into a few steps that we could work on, we started brainstorming a few ideas that could be made to the current design. Some of these ideas, which I will get into later during our final recommendations, include criteria such as the shape, how to hold it, as well as power sources and also data display, as seen in the pictures here. So once our team had enough ideas to think about how we could tangibly improve our device, we started to interview stakeholders and collect their feedback. Obviously, there were a lot of comments and helpful additions and insights that were given to us, but we decided to condense and summarize the ones that we took away into this slide here. The first feedback that we want to highlight is that we should consider the addition of a database and consider how a connection, particularly like an internet connection to a cloud-based server, could affect the costs. And the benefit of having a database is that you could store all the numeric temperature values into the device or some sort of memory component, so that later in the future you could look back at these temperature values and make a study on the population as a whole based on how many people have been affected by this virus given the presence of a fever, and see which areas have been the most significantly impacted so that you can allocate resources appropriately. The second comment that we considered was exploring an automated system that wouldn't require human input. So for example, maybe our device could be manually held by a machine at a station so that users would pass through the station and our device would automatically pick up the temperature. The next feedback that we received was extending the barrel to achieve 1.5 meters of a distance, and this is sort of a safety measure so that there is a good amount of distance being guaranteed whenever the device is used. And if the distance is not 1.5 meters, then a feedback system would tell the user that they're too close and should increase the distance from the patient. Some other feedback and comments that we received considering the context of Malawi's resources was finding cheaper and locally made microcontrollers, because currently in this stage, a lot of the components that we're using for our device has been through shipping from other countries. And so this has really affected the cost, but also the time it takes to produce one device because of shipping time. And another comment that we received was performing a cost analysis to determine whether importing parts is actually cheaper than assembling the device locally. And so at the end of it all, we decided to go through our brainstorming ideas again, as well as incorporate the feedback that we received from our stakeholders and make a few final recommendations. The first recommendation that we'd like to make is to consider the shape of the device to be a torch shape, a flashlight shape, or a water hose shape, so that the user is able to work with the device intuitively, because these are all common devices that have already been considered to be ergonomic. The second recommendation we would like to make is to include a color display for the severity of a fever. And so, for example, a normal temperature range would be highlighted as green. A worrisome value would be highlighted as red. The third recommendation would be to add small solar panels on the device, such that the device is not powered alone by the batteries. And so this would allow the device to be used multiple times throughout the day. And the last recommendation we like to make is to use the MLX 90614 sensor as the next step